Welcome to station number 3, finding irregular lengths on a coordinate plane. So you were confronted on the checkup with a triangle on a coordinate plane, and you needed to pick any one of the side lengths, but you needed to figure out how long they were. And none of them were on perfect units, so you had to essentially figure this thing out. Well, we've been actually working with this exact same topic for now 2 weeks, so we can use some of the skills that we've been playing around with when it comes to areas and lengths and square areas to figure out side lengths. So let's do just that. I'll show you how we can use some of these techniques. Here is our very first length. We have a length that spans across 3 units and up 1, and there's no ability for us to say that it's 3 units long or 4 units long. We need to be able to figure out the exact units for this baby. So one of the things that we can use is finding square areas. So we are going to do just that. What I'm going to do first is figure out a box. So this is our original side length, this blue side length, and we can figure out a box that goes along with that by looking at the slope. It goes up 1 and over to the right 3. So that means if I were going to make another length off this side length that was a perfect square, I could use that idea of using the slope and essentially turning it backwards. So I was going up 1 to the right 3. This time I'm going to go to the right 1 and down 3. So another side length that I could make is right here. And eventually I'm going to create a perfect box around here. I'm now going to go down 1 and to the right 3. And again, finish up this box. And then last to the left 1 and up 3. I think I said to the right 3. I shouldn't have said that. It should have been to the left 3. And finish it up. So this box is now a perfect square. If I could draw perfectly, it would be. So just roll with me here. So this box is a perfect square, and I need to figure out what the side length of this blue shape is. Well, we know that square roots essentially describe a side length of a square area. So let's use that exact concept to our advantage. So in other words, we need to figure out how big this square area truly is. So I'm going to break this area up and use the concept of finding the area of irregular shapes to figure out how big this area is. This is a 1, 2, 3, 4 unit space. It's a 1 by 1, 2, 3 triangle, so that's 1.5 units. Here's another 1.5. Here's another 1.5, and here's another 1.5. You might be asking, how did I figure that out with the triangles? Well, it was a 1 by 3 triangle, and to figure out the area of a triangle, I also need to divide those two side lengths by 2. So I get 1.5, because the area equation for a triangle is base times height divided by 2. So we have 1.5 plus 1.5, which is 3, and we have 2 sets of those, so I can say that I have 6 plus 4. This space is 10 units squared. That means if I were to describe this square area, it's 10 units squared, but if I were to look at the side length of that area, that is going to be the square root of 10 units. In other words, if we're to put this back into context of sort of unit squares that we've been looking at, we've also been looking at like a 4 by 4 square. And if I were to look at a 4 by 4, or not a 4 by 4 square, sorry, a 2 by 2 square, that's 4 units squared, and I know the side length of that is the square root of 4 or 2, because 2 times 2 gets me 4 units squared. So 10, or square root 10 times the square root of 10 equals the square root of 10 times 10, or 100, which is equal to 10, which is our area. So we're going to play around with this more and decide on whether or not we like this idea. So let's look at another shape. This time we have a shape that has various side lengths. Let's pick a side length. I want to find the area, or the side length red. So we're going to be looking at this particular side, the red side. In order to do that, we now need to create a square area around that shape. if I actually go in the direction of that's above the triangle, it looks like I'm going to go off the dot grid. So I'm going to shift my screen just a little bit. And I'm probably going to end up adding a couple of dots. So let's first figure out how far over I'm going. It looks like we're going 3 to the right and 2 up. So in other words, in order to make the rest of this shape, I am going to have to reverse that slope. I'm going to say I'm going to go up 3, 1, 2, 3, and over 2. Again, I'm going off this grid, and I will deal with it because I'm creative like that. And that was a horrible line to draw. I did that horribly. Retry. Kind of better, not really. Sorry. All right, whatever. I'm going to get over it. Then after that, I'm going to go over 3 again. 1, 2, 3, and down 2. 1, 2. Here's my new line that I'm going to draw. And then again, I'm going to go over 3. 1, 2, 3, and over 2. And I'm back where I began, which is exactly what we need. So this is a perfect square area. So let's figure out how big this square area is. Let's break it up into squares that we can count. I'm not going to do that. Looking at this, I'm confronted with a situation where if I were to connect dot to dot, I'm going to potentially be making some really weird shapes. So there's my dot to dots. I have a very small square in the middle, and then a 2 by 3 triangle, 2 times 3 divided by 2, which is equal to 3. So here's an area of 3, here's an area of 3, area of 3, area of 3. So 3, 6, 9, 12, and 14. So our space in the middle here is 14 units squared. And based on what we were just talking about, that means the side length of this particular red side is going to be the square root of 14 units. Because the square root of 14 times the square root of 14 equals the square root of 196, which equals 14. So here's a side length times a side length, and that gets us an area. Fun? Can we handle it? One last one to drive this point home. Here we are with an actual coordinate grid, much like our test. You had to connect the dots between various coordinate pairs. These are different than on your test. But with those coordinate pairs from there, we had to actually figure out one of these side lengths. And unless you know the Pythagorean theorem, which is not exactly what I'm looking to be tested here, but unless you know the Pythagorean theorem, you're not going to come up with the right square area. When I look at this, I see that I have a really long gold side, I have a really long blue side, and a shorter red side. So to make my life easy, I'm going to pick the red side. So it's a little less hard. But I'm going to use this exact idea of squaring off an area to be able to figure out a side length. So using that red side, I am going to go from, it looks like I'm going to the left 1 and down 5. So 1, that should be a 1, that's by 5. Then from there I'm going to go down 1 and to the right 5. So I'm going to make a new side. Oops, wasn't very good. From there, I could even go off this first dot over here. I could go down 1 and to the right 5. 1, 2, 3, 4, 5. Make another side. Oh goodness, that's not very good. And then my last side is right there. So from there, all we need to do is break this square up and figure out its actual area. Again, we're connecting dots to dots. So here's essentially a corner, and I'm going to connect it to this corner, here to here, here to here, and here to here. So I'm essentially making my triangles. This side is a little screwy. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 in the middle. And then we have 1 by 1, 2, 3, 4, 5. 1 by 5 divided by 2 triangles. So we get 2.5. And that goes for this, 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 and this triangle. So 2.5 times 4 total triangles gets me 10. So we have a square area here of 26 units squared. That means my side length is going to be the square root of 26 units. Test out your skills with the bits of paper that are at that station. Work yourself through the station activity. I hope this helps, and as always, if you have any questions, make sure you ask. Thanks so much.